Assalamualaikum students, this is my new video regarding potassium magnate as oxidizing agent. Potassium magnate solution is of purple color. It is used as an oxidizing agent, and also it is used to check the saturation of a compound. Like it can usually be decolorized when it is treated with an alkene. So let's start the video. First of all, cold dilute acidified magnate solution. And you see in the equation, if we add this solution to ethene can be converted into a diol. Diol means that ethene converted into a kind of alcohol with two OH groups. So this is a condition, this is a formation when we are using cold dilute acidified magnate solution. Then if we are using hot concentrate magnate solution, then what will happen? Basically, when we put this solution into any alkene, there would be three conditions. Condition number one, if with the carbon atom two hydrogen attached, then there is a formation of carbon dioxide. If with one carbon atom there is a R group attached, then there is a formation of aldehyde, which on further oxidation convert into carboxylic acid. In the third condition, if a carbon attached with two carbon atom, two methyl groups, then a ketone is formed. So just you need to remember these three conditions. So whatever questions we are solving are based on these two basic information, that with the cold dilute KMnO4 there is a formation of diols, and with the hot concentrated magnate solution there is a formation of CO2, carboxylic acid, or ketone, depend upon the number of carbon atoms. Here this is the first question, which is showing that how many of the molecule contain ketone functional group. If we oxidize this molecule of the beta carotene with hot concentrate KMnO4, you can see here the result. As you can see, this carbon atom, it have two carbon atoms, so one ketone form here. Now this one carbon atom, other ketone form here. Now this one carbon atom, so another ketone form here. Then this carbon atom attached to one and two carbon atom, another ketone form here. Then this carbon atom attached to this one and this one, so another ketone form here, and the same is the case here. If you count them, 1 2 3 4 5 6, so 6 ketone will be formed. This is another question. In this question you need to understand that a compound having carbonyl group, aldehyde or ketone, always give orange PPT with 2,4-DNPH. And in this question we are going to find out an alkene known as the Z, which when treated with the hot concentrate acidified solution form a compound which can give orange PPT with 2,4-DNPH. So a product can be, which is going to be formed here, it can be butane. So what could be the answer? So basically, if you see here, C, it contain with this C and this C, and one product is CO2 in this aspect, other is aldehyde. You can see here there is aldehyde of the ketone formation here, which convert into an acid afterwards, and that aldehyde will give a product orange PPT with 2,4-DNPH. For the rest of them, you can see here there is the formation of CO2, but C connect to two carbon atoms, so there is a ketone formation here. Here there is a formation of ketone plus carboxylic acid, and the last one CO2 plus carboxylic acid. So no ketone formation, so it is clear that answer is B, 2-methylpropene. So this is for the A actually. Then we have for the B, C, and then D. So only B could be the answer. You can see here, because it's a ketone formation, which can give a RePBT with 2,4 NDPH, and there is a CO2 formation as well. Clear? So this is another one, because if we treated but1-ene or but2-ene with the core dilute acidified, what will happen? You can see here it is very clear. There is no cis trans, because this carbon have 2 hydrogens, so no cis trans, but it is a formation of diol. Here again there is a formation of diol, and from all this information it is clear that one diol contain primary secondary alcohol group, one diol contain 2 secondary alcohol group. So the answer is C, X and Y. Here another question: which substance forms propanoic acid? Basically this is but1-ene. This is but1-ene. When it will break from here, so it means this carbon, which also contain have another hydrogen, will be converted into propanoic acid. This cannot be done. This cannot possible in case of butane, because 2 ethanoic acid is formed. Same is the case with C and D, in which no propanoic acid will be formed. Another question. This is the last question of today's video and the most important one, that you can see if we have a compound L with the formula C10H16 and reacted with hot concentrated acidified potassium manganate, compound M is formed. If you see closely, in M there are 2 ketones and 1 carboxylic acid. So on the basis of this basic information, let's see for all the compound. It will be break up from here 1 ketone, break up from here another ketone. Here 1 ketone, no ketone. So in all others there is no ketone formation. The 2 ketone formation and 1 acid formation can only be in A. So the answer will be A.